everyone. So I'm going to talk about the project number 1 for the EE100 course. The project is focused on the biomedical signal processing, and the specific topic is arrhythmia detection through electrocardiogram signals, commonly known as ECG. So if you recall back the lecture which I gave you regarding the biomedical signal processing, it was like lab 7 or lab 8 in multiple sections. So we talked about the variable monitoring and where we need to have a continuous monitoring system. And the one necessity was device miniaturization. And for that miniaturization, we talked about integrated circuit design. And then we talked about the low power operation. So the integrated circuit IC and then the low operation. And we said, okay, combination of these two makes a miniaturized medical device. Right, so that's what we talked. And then we saw an example or a system of an ECG where we have a patch sensor. It's on a chest of a person. We are acquiring that data to an analog front end, and then we are digitizing even on the same sensor using an ADC. And then we are doing some processing on this patch sensor or in this sensor so that we can extract the information related to the specific abnormality, in this case regarding the heart condition or specific cardiovascular disorder, which I also mentioned in that lecture, that okay, it's not only one single disease, rather it's amalgam of multiple combinations. And then once we are done with that, we can communicate to some remote place or for stimulation purposes. So that covers the complete flow. So in this project, basically what you are going to do, you are going to focus on this DSP part, which is going to, you are going to do that signal processing part from the data, which is acquired again in our lab at LUMS. So you're going to do the processing on MATLAB, and you're going to do some extra feature extraction, then classification of some abnormalities, which I'm going to describe in a while. But before moving forward, just again, let me recreate the same thing. We need to have a maximum clinical impact. So in order to achieve the maximum clinical impact, first thing is we need to have the acquisition. So this slide again shows the ECG electrodes connected to the chest of a person, and then multiple electrodes are giving some readings. Those readings are going to be interpreted by the cardiologist or by the technician. They are going to accordingly control the medication. But what my goal, what I was saying, why not we have a like a system which is autonomous, which is taking control. So for example, if we have a system which needs to take control, it needs to extract some information, and that what I was calling a feature extractor. So for that, we need to have some certain information. We cannot feed all the information again. Feeding all the information will need huge amount of memory. Feeding all information needs huge amount of processing, which is not possible in a very small environment or very small area, which I just showed you in a previous slide. So for those features which we will use today and which I'm going to describe are like R to R. So for example, the peak which is coming is known as R. So the distance between these two is known as R to R distance. So then there is a positive amplitude which is coming before the R wave is known as P wave. One amplitude coming after the R wave known as T wave. So there are different descriptions which again I'm going to mention, and you are going to detect in this project from the ECG pattern and then do some decisions based on that. What are those decisions? Again, in generic, they will be normal or abnormal, but we will categorize into three different other categories. One will be normal pattern, which we normally call sinus rhythm. The other is going to be the PVC, and another one will be ventricular tachycardia. And finally, we need a recording. But in this project, you will mainly focus on the feature extraction and the classification part, implementing on MATLAB. The data already we acquired and we will share with you. So let's moving forward, and I will introduce the electrocardiogram signal ECG. So as you all know, in our heart, we have 4 chambers. So if we divide our heart into 4 chambers, the upper chamber is known as atrium, and the lower chamber is known as ventricle. So the atria has left atria, right atrium, and similarly ventricle has left ventricle and right ventricle. So the whole this pattern, which we normally call ECG, is basically conduction of electrical impulse from the artery to the ventricle. So from up to down, the blood flows, conducts, and that whole process is known as an ECG cycle or ECG pattern, one complete cycle. So when blood comes, oxygenated blood comes, it pumps the blood, goes out, this whole one process is going to form this ECG pattern, which is shown as an animation here. So for example, you can say some peak is going to come as we are going to have, and that peak is P wave signal called atrial depolarization, followed by a Q wave, which is a dip, and then followed by a QRS duration, which is basically ventricle depolarization, and then there is an S wave. So this is a peak and this is a dip, and then after S wave, the next maxima or next peak which is going to come will be in the ventricle repolarization, and that is commonly known as T wave. So all of these waves, which are T waves, R waves, Q, S, P, their amplitude and the interval in between them is very much important, and that tells how your heart is functioning. So in general, this is the whole, it's a more complicated story, but we are going to have some features based on that, and we are going to detect some abnormalities in this project, right? So if you want to see, so in the activation of the artery, how it's happening, the blood is flowing through, then the activation of ventricle, the blood is going through the lower half, and then in the depolarization or the recovery wave, the blood is going back. So it's like flowing and then oxygenated blood is coming back. So that's the overall cycle, the way things happen. So if we want to talk about further, so there are some cases which we normally call cardiac arrhythmias, meaning some abnormality. So in generic, we divide them into 4 ventricular rhythms or ventricular arrhythmias. Basically, those rhythms are divided based on how your R to R distance is. Or in general, we can say what is your beats per minute is. So if, for example, your beats per minute is between 60 to 100 for an adult person, like in your age. So if the beat per minute is 60 to 100, meaning this R to R distance or these R peaks in 1 minute are coming between 60 to 100, this means your rhythms are normal, okay, or regular rhythms. If your rhythms are fast, meaning more than 100 beats per minute, then we can say it's a fast heartbeat or tachycardia, right? So you can see that it's relevantly more closer. If your heartbeat is slow, there's a typo where it should be less than 60, not 60 to 100. It's just less than 60 beats per minute. Then we normally call it a slow heart rate, or we also call it a tachycardia. And these definitely, the fast and the slow is not a good thing. But the worst thing is the irregular heartbeat, where we have not a fixed pattern between R to R peak. And for each beat to beat variation, there is some variation which is being recorded. And if that variation is more than 10 beats per minute, then it's something which needs to be taken care, and we need to most likely visit the cardiologist. So this is the one discrimination which you are going to see in today patterns which are provided to you, the ECG data. So you are going to detect from those patterns that what is the condition, and is normal, is it fast, slow, or irregular. Moving forward, there's a broad categorization which we normally, which the doctors normally see based on this QRS complex or this overall pattern of this ECG. So in that pattern, the features which mainly act is basically the wider QRS complex, the QRS complex which you just see like Q wave, R wave, and S wave. So the width of that, the amplitude of that, it has huge significance, and it tells a lot of things to a cardiologist that, okay, if you have a certain wide area in this QRS complex, or if your R wave is certain magnitude, then definitely there is something wrong, or there's something need to be fixed. Similarly, if the T wave and the QRS deflection is opposite direction, normally they both are positive. But if the deflection is positive, is on opposite direction, also it has some significance, some information hidden. P wave is absent, that's also some sign for some abnormality. So in general, there are more, there are a lot other than just mentioning some of them, because we are not like studying the overall scenario, but we will see we can use these biomedical signal processing to detect those by making some further complex systems. but we can use basically the R, S, and T wave, that's like standard waves, and their amplitude and their indices to detect most of the scenarios. So in this project, what you are going to focus, you're going to focus on premature ventricle contraction. That's a condition which is earlier stage, not that much severe, but like that's a preamble, and the first thing which the doctors notes or the cardiologist notes from the ECG pattern are the PVCs. So that's in that sense very much important. The second comes the ventricle tachycardia. That's a severe scenario which needs significant care, and it needs to be reported to the cardiologist so they give you medication or follow a specific path. Then there are more further severe scenarios like ventricular fibrillation, flutter, asystole. So there are follow-ups too. But in this project, you are going to mainly focusing on these two first scenarios, which can be basically easily calculated or classified based on this R, S, and T wave amplitude and indices. So I will go one by one regarding the description of PVCs and VT, so that, and then specifically what are the tasks which are going to be required in the project as deliverables. So the premature ventricle contraction, as the name suggests, is premature, meaning it's not that much stringent, but definitely it's an early sign. So this early sign need to be checked whether it's a real sign or a false alarm. Basically, it is an electrical irritability in the ventricle conduction system or a muscle tissue. If it's a muscle tissue, then something is okay, then that's false alarm. But if something in the ventricular conduction system, then need to be taken care. So how we can detect it? Basically, it has two forms, PVC1 and PVC2. So we are only going to focus on PVC1 just to simplify the problem. So in the PVC1, you can have the RR interval smaller than the normal. Okay, so for example, if this is a one R peak, this is another R peak, distance between these two R peak is less than 0.6 second, then this is one of the condition. Then second condition comes, you might have the ST interval longer than normal. For example, if it is longer than 0.28 second, the distance between these two, then this is also one of the features or one of the symptoms for the PVC. And just to mention, among these three basically conditions, any two of them should be there so that we can declare a pattern, an ECG pattern as PVC type 1. Okay? So एक से काम नहीं चलेगा. So you need to have at least two of them. So अगर खाली RR interval less than 0.6, so this is not the necessary condition. That can be a tachycardia, but it's not going to be a PVC. Whereas अगर आपके पास कोई सी दो coexist कर जाएं, then this means it's a PVC type 1. तीन भी हो जाएं तो definitely, लेकिन दो are minimum required. And then there's a high T wave amplitude. अगर T wave amplitude normal इस तरह का है, if it goes higher, more than 100, and 100 is an ADC code, which I hard coded and provided you based on this data, so that you don't have, ultimately it's more like a patient specific approach that will be more complex. So I hard coded the value and said, okay, if it goes more than 100 in this data, it's going to be P wave, PVC type 1 if any one of the above scenario also gives a positive sign. So these basically three conditions which you are going to detect from the ECG data which is provided to you, and you are going to decide whether the data is type PVC1 or normal sinus rhythm. Also, and this is just a graph or realistic ECG pattern when you go to hospital and the doctor provides you, or the sports person provides you, showing that this is the ECG pattern. And conventionally in our hospitals, we have only access to the paper format. Moving forward, then comes the ventricle tachycardia. That's an alarming situation, extremely unstable rhythm. VT is most common cause of sudden cardiac death, so we need to be cautious. So how we can detect three or more continuous or occurrence of the PVC, meaning in a row, if we get three PVCs, this means this is a case of VT and we need to be careful. This doesn't mean VT comes and the death is there, meaning this is a more alarming or realistic sign. Now you need to visit the doctor or you need to do a proper follow-up checkup. And that leads to ventricular fibrillation. That is basically the fibrillation is a sudden cardiac arrest which happens, and that can directly lead to the death. So we need to be cautious that VT is the one step before the ventricular fibrillation. So you can see this is like this is basically a ventricular fibrillation scenario where not only three, it's a consecutive PVC is coming. So it's a VT, pure case of VT, and then it's leading to cardiac arrest. So that's what we need to be cautious. So that's why in this project, we are going to talk of mainly we are going to focus on the PVC, and based on the PVC, you can detect the ventricular tachycardia. So I will a little bit more describe the features which you are going to calculate in this project, and then we'll discuss a bit about the state flow and the individual tasks. Right, so ventricular tachycardia, what things can be helpful? We need to have certain features. Those features are R wave amplitude and their indices, mean where they are occurring, because so that we can find the relative distance. S wave amplitude and indices, Q wave amplitude and indices, similarly T wave amplitude and the indices. We just talked about these all waves, and the length of the PT wave duration. So from P wave to Q wave, how much time it takes. So you will have both indices, you will just subtract these two and you can find easily, but that also has information you might not need in this project, but definitely that is one of the features which is significantly used. And on top of the spectral energy of the bands. So that is very much important, that what is the spectral content in a specific band. So for example, we use quite a lot this band of 1 Hertz to 3 Hertz for the calculation of another significant basically atrial tachycardia, another significant condition, but not in this one, but you still need to calculate the features. And for that, we need to have that calculation after, for example, after every 5 seconds or even less. But at this moment, you are asked to find the spectral energy content of band of 1 to 3 Hertz. So you need to have a band pass filter, having cutoff, lower cutoff at 1 Hertz and higher at 3 Hertz. And then you need to have that data extracted out, calculate the spectral energy. So if you are going to calculate energy, you're only going to take the positive values. If you want to take square, this relative, you can also do that thing, but you're only going to count towards the positive values. And then you are going to sum those values for every 5 seconds, and then you have to report. So for example, if there's a 20-second data, you will have overall 4 values, and each one is telling spectral content at the end of fifth second. So that's information which normally we use for the classification a lot in biomedical signals and explicitly in the ECG. Then comes the heart rate and heart rate variability. We talked about the R to R variation, which tells us about the variation which is happening. So in general, we can find heart rate, but the variation across each cycle is very much important. And that tells a lot that how your heart is behaving, for example, for the abnormal conditions. So you are going to do that in this project too. Then you will talk about the PVCs. For the PVCs, you will be using mainly the R to R variation as those 3 symptoms I mentioned, ST interval duration from S wave to T wave indices, and then the T wave amplitude. So you are going to be, you're going to see whether any of the 2 conditions occur at the same time. This means, or in the same pattern or same cycle, this means the pattern is basically an PVC positive. And then continuation of 3 PVCs is basically a tachycardia scenario. So that's what you are going to do. And for the HRV, somehow you will have some similar plot. For example, beat to beat cycle is shown here and shows it varies from like around 54, some sort of up till 90. So there's a good amount of variation, which is not a good thing if the person is in the resting case. So this means there is something wrong. So this sort of variation shouldn't be there. So you can see on the x-axis, there is time, and the y-axis, there's beats per minute. Now, if we talk about the implementation, what's the approach? Again, you can follow multiple approaches as you feel comfortable. So I am providing you one approach, and that is not only a state flow diagram or state flow approach. That's more easy or intuitive to look and to understand, and more easy how the system works. So for example, first thing, you are going to have a digitized ECG data, which is acquired. So you can downsample this data. So it's provided to you, you can downsample so that you can get some benefits from the processing side. Might be not that much evident in the MATLAB, but this again is provided you the task to downsample the data. So initially, for example, you will be in one state. One state meaning one condition you are. So you are waiting for what? You are finding the maximum value. ठीक है? तो आप इस विंडो में हैं and you're finding the maximum value. So once you find this maximum value, so you will declare in this window, this is the maximum value, and then maximum value क्या होगी, वो R wave होगी, और उसके क्रॉस इंडेक्स क्या होगा, R wave का इंडेक्स होगा. So जो इस विंडो में एक maximum value होगी, that will be R wave, and the index will be R wave index. So that's we can find R wave. So once we find R wave, we will go to next state. तो आप इसको एक if condition से कर सकते हैं. Once you find this thing, then you can only go to the next state. ठीक है, तो आप next state में आ जाएंगे. In the next state, what you are going to do, you are going to find the Q wave. Q wave क्या थी? The minima which comes before the R wave in a certain time window. वो certain time window क्या है? 0.05 second. So what you need to do, आपने R wave के जब index find हो जाएगा, उससे 0.05 second पहले you have to find the local minima. जो minimum value इस window में होगी, for example इस window में होगी, you will claim that as a Q wave, and the index corresponding will be Q wave index. So you can just find this thing. Again, once you find this thing, you find this, for example, if this is satisfied, what you will do, you will go to next state. Next state क्या है? Finding the P wave. P wave क्या चीज है? Again, going back, if you see a local maxima, a maximum point आ जाएगा किस duration में? Some duration back the Q wave. वो duration कितना है? It's provided to you 0.16 second. So अगर Q wave से एक window draw कर दें 0.16 second पहले आप जाएं and try to find कि उसमें आपके पास मैक्सिमा किस पॉइंट पे आया है. वो जो पॉइंट होगा that will be the P wave index, और जो वैल्यू होगी that will be the P wave amplitude. So you can find the P wave amplitude. So but till now we find R wave, we find Q wave, and we found P wave. Remaining are S and T. जो S and T है that will be on the right side of the QRS complex. वो किस तरह find करेंगे? Next state में आ जाएंगे जब P wave हो गया, then we will look a local minima after the R wave. So ये after the R wave हम 0.05 second में इस local minima की विंडो देखेंगे, उसमें सर्च करेंगे जो भी local minima इधर वैल्यू होगी इस विंडो में, that we will claim as an S wave, and उसका जो amplitude होगा that will be S wave amplitude. So origin से जो amplitude find करेंगे that will be S wave. So we can find an S wave accordingly. After that, what we are going to do, we will be in the next state and we will be finding the T wave. अब इस S wave के बाद एक certain window 0.42 second के अंदर जो maxima आता है that is a T wave. So we can locate the T wave accordingly in this window. And जब हम कर लेंगे, we can wait for 0.5 second so that we reach to the point कि हम कोई और चीज ना, we don't want to detect unnecessary an R wave. So we wait for 0.5 second and then we can move towards the again repeating this cycle and R wave. So we can repeat this cycle again and again. So it's a for loop. एक loop है जिसमें आप हैं, while loop है, and you are detecting. So you have to go until the end of the overall cycle जो आपको ECG data provide किया हुआ है, ठीक है? So that's basically you can have this implementation flow. So intuitively think, and then you can just replicate that into a MATLAB code. अब individual tasks क्या हैं आपके? So the individual tasks are basically mentioned here. So first task is basically the data is provided. So you are provided two data files, ECG1, ECG2. So they are MAT files. So you can easily download and then upload on your online or the way you are want to upload. It has information about the ECG data and the sampling frequency. You need to plot both of them on an x-axis, and then you need to mark the amplitude, and you can see कि वो ADC code किस तरह है. So पहला काम just visualization का है. You just need to identify the cardiac arrhythmia types, के number of specific arrhythmia कब occur हो रहे हैं by again naked eye. You don't have to write anything. And in both जो MATLAB के आपके पास है, so you get familiar to the things and you can discuss with your TAs in your specific office hours or your specific dedicated hours, okay? And then you need to you can also zoom in and you can visualize. For example, you can zoom in here and you can see these are the normal patterns, and when I zoom in you can see कि इसमें ये क्या, ये R है, ये आपके पास T wave है, ये आपके पास Q है, ये S है, ये P है. So you need to just mark manually, at least you are understanding. जब तक आप manually नहीं कर सकेंगे, then you cannot proceed towards writing a code which can automate the thing. The second thing is that you need to find the heart rate variability, heart rate, and downsampling the data. So you will downsample the data 5 times, which is provided again. The instructions are provided to you. So, and you need to basically show the both down sample and the actual data. You need to remove the DC value ताकि आपकी offset है उसको remove कर दें. Then you need to find the local maxima to find the R wave. तो आप R wave find कर लेंगे, and then you need to find the distance between R wave, and that will basically give you information about the your heart rate. You can also use the frequency domain. It's totally your choice, but ultimately we want the heart rate and the heart rate variation. So heart rate variation across the varying time. So we want the ये अगर ECG pattern है, so we want a plot जिसमें आपकी जो beats per minute हो वो किस तरह टाइम के साथ वेरी कर रहे हैं. We want this information on the down sample data. Then the third task, again जिस तरह कहा था कि we need to detect some features. हम सारा data नहीं use कर सकते. So these are again those जो features आपके पास mention किए, the 6 features. You are going to find out these features from the ECG data. So for task 3 explicitly, you will use the ECG1.mat, and you will find all of these features and key values, and then you are going to plot them on the जो आपके पास plot होगा. You need to mark them on those plots. कि R wave has amplitude, for example. This is R wave, this is Q, this is S, this is P, this is T. So you have to mark them specifically for the overall data, and also you need to find the spectral energy content and the जो आपके पास P to T का एक interval है उसको भी you need to find the value. So ये आपको explicitly find करना होगा in the task 3. In the task 4, you have to do the same thing for the ECG2. ECG1 is relatively straightforward case. ECG2 is a little bit means not that much straightforward. If your algorithm is more robust, then you might be able to find all of them. But if it's not that much robust, you might have some issues. So you will do that thing, and also you are going to find this discrimination जो हम लोगों ने बात की थी regarding the different cycles, normal, bradycardia, tachycardia, and the abnormal pattern. So you will find out also that information from the ECG data, and you need to provide your justification कि ये क्यों है. For example, definitely if it is coming like this, the justification is already there, but you just need to again reiterate the same point. So the same thing, you need to mark the features for this pattern, which has a lot complex patterns, and then you also need to find the state कि normal has abnormal pattern है, bradycardia है या tachycardia. And in the task 5, it's basically the classification that जो आपने वही features use किए थे, उन्हीं features की base पे you need to decide कि whether वो 0.2 second window achieve कर रहा है, T wave is amplitude ज़्यादा है, R2R का है, सिर्फ 2 of them occurred, you can say PVC है. अगर कुछ occur नहीं हुआ, तो then you can say it's an arrhythmia detect, no arrhythmia detected. Similarly, अगर वो PVC detect हुआ है या ventricular tachycardia detect हुआ है, then you need to mention the time at this point पे, and then you need to display this window. So just you have to do a basic this sort of one step. So that's all. The instructions are up on the manual. Make sure to go through them, discuss with your group mates, discuss with your basically fellows, and form a group. And then on Monday, you have whatever the queries, come with all the queries, and we can like take all the questions. So we finalize, you will finalize your groups by Monday. Again, explicitly, all instructions are detailed in the manual. You need to adhere to them since we have very much short window, and then you need to basically focus on your project deliverables, and you have to follow the timelines. Again, we don't have relaxation. Previously in the lab, yes, we did relaxation, but now since the grade submission and the grade finalization is there, so we might not be able to entertain your extension requests. So that's why just make sure start early. The things are the same which you are doing. It's not like even it's almost the same level what we have done, but just definitely new signal, new techniques, so we get overall idea. If you have any questions, you are more than welcome to come into the Monday session. And even if not, you need to come, so you listen from others what they are having questions, because sometimes you are not getting some, you are feeling you know everything, and there are some points you miss. So make sure you come and get benefit from that. Thank you and best of luck.